This example examines what happens as the firm varies employment of two inputs. I'm going to call the two inputs L and K. The example has some assumptions. First, we're going to assume the wage for L is $5 per unit. We're going to assume the wage for K is $15 per unit. We're going to assume the extra output is 100 when L increases by 1, and the extra output is 200 when K increases by 1. Here are the implications of our assumptions. First, the marginal cost of extra output when L increases is 5 cents per extra unit. It's the wage rate, 5, divided by the extra output of 100. Second, the marginal cost of extra output when K increases is 7.5 cents. It's the wage paid for K, 15, divided by the extra output produced by another unit of K, 200. These two, since the marginal costs are not equal, it means that total cost, holding output constant, decreases as the firm employs more L and less K, because the marginal cost of extra output when L goes up is less than the marginal cost of extra output when K goes up. The table below shows what happens at 3 combinations of employment. The extra output, well, let's start with row number 1. Row 1, we start off with K is 8, L is 10, and we'll assume quantity is 100. Given the assumptions about the wages, this means that total cost is 170. So now the question is, can I produce 1,000 units of output at a lower total cost than 170? I've submitted to you, and the answer is yes. Since the marginal cost of extra output is lower for labor, is lower for L than for K, the firm can reduce total cost by employing more L and more K. Let's work through an example to see if we can make that happen. So the first thing I'm going to do is say, well, what happens if I employ one more L? If I employ one more L, my total cost is going to rise by $5. Each L costs me $5. But output's going to rise by 100 because the marginal product of L is 100. So when L goes from 10 to 11, and K stays constant at 8, output rises to 1,100, and total cost rises to 175. Now let's do the same thing. Let's let L go from 11 to 12. Again, the extra output would be 100. So output would rise from 1,100 to 1,200. And since I got to pay $5 for each L, total cost will rise from 175 to 110. So now I've spent $10 more, and I've got a total of 200 more units of output. Now let's suppose that we fire one of the Ks. Let's make K go down from 8 to 7 and keep L constant at 12. This reduction, or this firing of K, means that my total cost will fall by $15. Each unit of K costs me $15. So when K goes down from 8 to 7 and L stays constant at 12, total cost will fall from 180 to 165. Now, we'll give it some output. That last unit of K produced 200 units of output. So when I fire the 8th K, I'm going to lose 200 units of output. So output is going to fall from 1,200 down to 100. But now look at the final result. Compare row 1 with row 4. In both cases, output's 100. I got a total of 200 extra outputs by increasing L by 2, and I lost 200 units of output by firing one of the Ks. The net result is output remains constant at 1,000. But also notice that total cost goes from 170 down to 165. I paid $10 more when I hired 2 Ls, but I saved 15 when I fired 1 K.